We have discussed about the fusion welding in the previous lecture. Now we will discuss about the solid state welding, which is the another type of welding process. The joining of two metal in this welding can be done with the help of pressure only. Only pressure is required to weld the joints, and sometimes we require the combination of heat and pressure to join the metals in solid state welding. In solid state welding, no melting will occur as compared to the fusion welding. In fusion welding, if you want to join these two metals, you have to fuse or melt this interface. But it is reverse in the solid state welding. No melting will occur, only this surface will go into the plastic state with the help of electric resistance, electrical resistance. Due to electrical resistance, due to electrical resistance, this interface will go into the plastic form. Plastic form means this part will not regain its shape. Elasticity will remove from the interface of these two base metals. Electrical resistance, and this electrical resistance is achieved by current, and due to this electrical resistance heat will create, and because of that heat, this interface will go into the plastic state, and force is applied at the both ends, and due to this force, atom of this base plate and atom of this base plate will fuse together in plastic state, and after some time this joint will solidify and form a strong bond. This is solid state welding. In solid state welding, the main and distinguished feature is that no melting will occur between the base metals. You can weld or you can form a metallurgical bond between two similar or dissimilar metals in solid state welding. In solid state welding, there are three types which are commercially used: diffusion welding, friction welding, and ultrasonic welding. In diffusion welding, heat and pressure is used to join the two parts. You can join parts which have a uneven surface. Part one is uneven, has uneven surface, and part two is also have one has uneven surface. You can weld these two parts. What you will do in diffusion welding, if this is these parts are the non-ferrous parts, are the non-ferrous part, what you will do, you will place these two parts in a very intimate contact, a close contact. Electrical current will apply, and due to this electrical current, electrical resistance will create, and due to electrical resistance, heat will generate at the at this surface of both part. And due to heat, this both part will go into the plastic state, as I've already explained you, and force will apply at both ends of the parts, base metals or base metal parts. If both metals or both parts are ferrous, made up of ferrous non-ferrous materials, you will place the both the parts in the chamber. Electrical current will apply, and due to electrical current, electrical resistance will create. Due to electrical resistance, heat will generate, and heat is responsible to bring the interface of both the parts into the plastic state, and force will apply, and atom of this metal and atom of this metal will fuse together or will join together. This is called diffusion, when migration of atom from high concentration to the lower concentration, or from one part to the another part, migration of atoms. During the diffusion welding, as you can see here, step 1, both part placed together. Step 2, heat and pressure will apply, and in step 3, diffusion is going diffusion is occurring between the interface, and in step 4, a fine grains is formed during the diffusion welding. This is the practical picture of diffusion welding. This is the hydraulic press. If I have explained about the non-ferrous material, if you want to join the two parts which are made up of ferrous material, then you have to place the ferrous parts into the vacuum chamber, because ferrous part are made up of iron content are present in the ferrous materials, and these ferrous materials can react with the oxygen which are present in the environment. So uh, both the parts, if they are made up of the ferrous material, you have to place the parts into the vacuum chamber. Vacuum can be created by mechanical electrical pump. One more thing, in non-ferrous material diffusion welding, you will apply force with the help of inert gas. No mechanical or no mechanical assemblies or presses will use in diffusion welding of ferrous material. In diffusion of welding of in diffusion welding of ferrous material, you will use the hydraulic cylinders or hydraulic press for mechanical pressure. Here you can see these two are the ferrous plates, and they are going to be welded with diffusion welding, and this is the press upper part and press lower part, and they are operated with the help of the hydraulic actuator or the hydraulic cylinder, or with the help of hydraulic cylinder. um, the disadvantage of this welding is very time consuming, and one more point is that initial investment is very high uh, in diffusion welding. The advantage is that you can weld similar dissimilar metals. You can weld ferrous non-ferrous materials. You can weld cobalt with copper. Both are the different materials. So this is the advantage of this diffusion welding. Diffusion welding is use of fabricating complex parts for the aerospace industry. This diffusion welding is widely used in nuclear industry. Um, Titanium, beryllium, zirconium, and metal alloys. Refractory metal alloys is it is the copper and the tungsten alloys. You can weld all these kind of materials: titanium, beryllium, zirconium, and refractory metals with the help of diffusion welding. Diffusion welding bond are very strong bond. They have a high tensile strength, and you can use in if I talk about the automotive industry, you can weld the axle with the chassis with the help of this welding. I have already explained you about the diffusion welding. Now I will explain you regarding the friction welding. Friction welding, it is the type of solid state welding which is used to join the metal with the combination of the frictional heat and pressure. The friction in this welding is induced into the or between the two surfaces by mechanical rubbing. I will explain this welding with the help of one picture. When these are the two parts which are going to be welded, part one is rotating condition, and part one is rotating because it is installed into the rotating chuck, and this rotating chuck is rotating with the help of the motor. The other end, or the part two is in a stationary condition. It is installed into the non-rotational chuck, but this non-rotational chuck will move backward and forward with the help of the actuator. And in the step two, as you can see, when both the metals are both the base part are brought into the contact, and due to rotation between the base metal, friction will generate, because one part is rotating, other part is in a stationary condition. When both the parts are brought into contact, friction will generate, and that friction will produce the heat, and this heat will be responsible or sufficient for a strong joint to form, because due to this heat, the interface or the surfaces of the both the base metal will go into the plastic zone and become soft. When you apply the force at from the both ends, and due to this force or the friction pressure, mechanical pressure will generate, and mechanical pressure is responsible to form the strong joint. This is the basic procedure of the friction welding. This weld zone, its size depend upon the three types: amount of the heat generated, thermal conductivity of the material. If the thermal conductivity of both the materials is high, you can weld the part quickly. Mechanical properties of the materials also encounter in uh, friction welding at elevated temperature. Elevated temperature is actually below the melting point of materials which are going to be weld. Number two, uh, the friction welding has three types: inertia friction welding, linear friction welding, friction stir welding. In inertia friction welding, I will explain you this type of welding, friction welding, with the help of one picture. This is the rotating part, and this is the stationary part. And this rotating part is rotating with the help of the flywheel. And this part, flywheel, is in rotating machine so that it has a rotational kinetic energy. And this rotational kinetic energy is required for frictional heat at the interface of both the parts. And that frictional heat will be responsible to bring this interface into the plastic zone. When both the parts will go into the plastic zone, or both the surface will go into the plastic zone, heat pressure will apply from both the ends, or axial force will apply from both the ends, and due to this force, joint will form at the interface of base metals. The application of the inertia friction welding: point 0.4 inch or 10 diameter shaft are welded into the automotive turbocharger impeller. Normally, it has happened in the uh, sports car like Ferrari, Porsche, BMWs. They are using the turbochargers to boost the speed. What happens in the or actually in linear friction welding, there is one reciprocating part instead of rotating part. This part will move upward and downward. The stationary part is brought into the contact with this reciprocating part. Due to this reciprocating motion, frictional heat will produce, and that frictional heat will responsible to bring this interface into the plastic zone. Plastic zone means this the surfaces of both the base metal will become soft, and force will apply at both the ends. And due to this force, mechanical pressure will generate, and this pressure will complete the formation of weld joint. And this joint has very good mechanical properties. Normally, in Airbus or Boeing, actuator shafts are welded with the help of linear friction welding. There is one more type, friction stir welding. What happens in the friction stir welding? You can form only a butt joint with the help of friction stir welding. Stir means mixing. Stir means mixing. Two parts are brought in contact. There's one mechanical tool. This mechanical tool has two parts. Or one is the shoulder and the other one is probe. Shoulder has large diameter, and probe has a small diameter. Now, the diameter of probe is 2 mm to 4 mm in diameter, or the height of the probe is 6 mm normally. During the welding, this mechanical tool will rotate, and this probe will go completely inside the base metal and start mechanical mixing. Due to mechanical mixing, additional heat will generate, and when this probe will go inside the base metal, this shoulder will come in contact with the base metal, and due to this contact, frictional heat will generate. This frictional heat will cause the interface to go into the plastic zone, and due to this probe forces the base metal to fuse together, to join together and form a weld seam. There is one advantage of this is friction stir welding: no shielding gas will use, no filler material will use, and also uh, toxic fume will not produce during the welding. But there is one disadvantage: when at the end of the welding, when the probe will come out, it will create one hole over the surface of the base metal, and you have to fill this base. You have to fill out uh, this hole with the help of some filler material to prevent it from leakage or to prevent it from the atmospheric oxides. I will explain you about the ultrasonic welding. It is a type of solid state welding. If you want to make a lap joint of two parts, this is the fairing surfaces. The fairing surface of two components. These two fairing components are, or this fairing surface are subjected with static normal force, and also oscillatory shearing stresses are acting at the interface of the two components. This oscillatory shearing stresses are created by or caused by vibratory motion. This oscillatory shearing stress has great significance in ultrasonic welding. I will explain this significance of the oscillatory shearing stresses later in this topic. First, I will explain you ultrasonic welding apparatus. The components are going to be welded are clamped under the clamping rod and the anvil. Both the parts are placed over the anvil, and clamping rod is fixed with the mass M. And transducer is also coupled with the clamping rod, and at the end of the clamping rod, sonoto tip is attached. This transducer is connected with the power supply, and from this power supply, electrical signal will go into the transducer. Transducer will convert this high electrical signal into the mechanical vibrations. And due to mechanical vibration, this clamping rod will oscillate in this direction, right and left. And due to this oscillatory motion, oscillatory stresses will create at the fairing surfaces of the two metals. This oscillatory stresses will cause plastic deformation, and due to plastic deformation, temperature will rise at the interface of the two components. The temperature is the elevated temperature, and it is equal to the one third of melting point of both the base metals. This oscillatory stress is also responsible for breaking the oxide's flame and contamination if they are present at the interface or on the surfaces of the base metal. And additional static force is applied on the upper part of the base metal. This force is used to produce a strong solid joint between the two base metals. One more thing, what is the function of the sonoto rod? Sonoto rod tip is used to transmit the oscillatory motion on the upper work part, and it is also coupled with this sonoto rod is also coupled with the transducer. The oscillatory motion or frequency of the oscillatory motion is about 10 kilohertz to 75 kilohertz. Ultrasonic welding is used to weld the small thickness of around 3 mm to 6 mm. It is also used to weld the uh, thermoplastics. It is also used to weld the thermoplastic materials. It is extensively used in the automobile industry for packing the uh, automobile parts with foil. It is also used to create a lap joint of aluminum and the copper, and it is also used to weld the sheet metal parts of thickness 3 mm to 6 mm. This ultrasonic welding is highly used in industries, but this ultrasonic welding will require the moderate skills to operate the apparatus. This is all about the ultrasonic welding. I will explain you about the welding defects, because welding defects are the welding discontinuities, and these discontinuities can be caused by a insufficient or careless application of proper welding technologies. So the common defects which are commonly faced in during welding is crack, porosity, solid inclusion, incomplete fusion, and imperfect shapes. Cracks may, as you see here, these are the cracks, longitudinal toe cracks. Longitudinal cracks are in the axial direction of the bead. Transfer crack normally are in the perpendicular direction of the bead. Toe cracks will form just on the top of the base metal, and the under bead crack will cause at the under the bead here. Cracks are generally caused from a combination of different factors. Normally, high temperature gradients will cause thermal stresses, and thermal stresses in the weld zone. This is the weld zone where weld beam is formed. This is the weld zone, and here thermal stresses will generate due to high temperature, and due to high temperature, cracks will form. Or one more thing is the variation in the composition of our well zone that cause different rate of concentration during cooling. These are the factors which are responsible for cracking. You can prevent the cracks by modifying the joint design to minimize the thermal stresses from shrinkage during the cooling process. And number two, avoid rapid cooling, because most of the time operator will try to or solidify this bead with very rapidly. So try to avoid the rapid cooling of the welded components. Number two is the porosity. Porosity is the very common defects face in the face during the welding. Porosity may be caused by gas release during melting of the weld area. As you know, gases are or fumes are produced during the melting, and these fumes or gases can be or normally are trapped during solidification over the surface of the bead. And there are some contamination like dust or greasy surfaces. uh, these are the things which can cause porosity. Porosity can be prevented by proper selection of the electrode and filler material, which is very important. Reduce welding speed to allow time for gas to escape, because we need to prevent this bead from fumes which are that are produced during the welding. So we need to reduce the welding speed to allow the gases to escape from this weld zone. Number three is the solid inclusion. Now, sometimes in some books, solid inclusion is called the slag inclusion. These inclusions are compounds like oxides, flux, and electrode coating material are normally which are trapped in the weld zone. Um, and this slag or solid inclusion form if shielding gases are not effective during welding. So contamination from the environment that also contribute in this type of defect. You can prevent this defect or during welding. Clean the weld bead surface with the help of the wire brush. Normally in surface arc welding or electric arc welding, the base metal surfaces will be cleaned, or are these surfaces are that are normally cleaned with the help of the wire brush before the welding process. And one more thing, you can provide a sufficient gas, shielding gas during the welding process to prevent the surface. Number four is the incomplete fusion. As you can see, there is some spaces remaining to fill the molten metal or to fill the filler material. This incomplete fusion produces poor weld bead. As you can see, spaces here, there is there should be a proper weld bead, and due to incomplete fusion, not proper weld bead will form here. Uh, this incomplete fusion will cause by raising the temperature of the base metal. If you raise the temperature of the base metal, so this defect can be faced. And cleaning the weld area before welding, you can prevent this defect, or you can save the material from this defect. Before the welding, you have to clean the surface of the weld. Number 5 is the improper shapes, that is related to the weld profile. You can see there are very improper shapes are formed, or very improper joints are formed. uh, this is the picture of the gold weld. Good weld should be look like this: a properly filled good weld till the end of the, or till the root of the joint. Here you can see this is underfilled, not completely filled. This is overfilled, and this is undercut. Overfilled means the material, or the molten material, and the filler material are over the surface of this, the base material. You can see this pockets, small pockets, that is porosity, as you can see in the well bead. This is the imperfect, or the imperfect shape, or the bad weld profile. The good weld profile should be look like this: properly filled. There is no porosity, no underfilled, no undercut. Undercutting results from the melting uh, away from the base metal. And this underfilled results when the joint is not filled completely with the proper amount of weld metal, right? And overlapping is the discontinuity. The more material is showing or is appearing over the surface of the base metal. So you can save, or you can prevent your joint from improper shape or imperfect shape by using the proper filler material, by using the proper gas to prevent the this base metal or the filler material from the environment. In this topic, I will explain you brazing and soldering. Both are the type of the welding process. Soldering and brazing both are exactly same in nature, but there is a slight difference of temperature, melting temperature. First, I will explain you brazing. Brazing, it is a joining process in which filler metal is placed or filled between the fairing surfaces, which are to be joined or to be welded. And the temperature is raised sufficiently to melt the filler material. The filler material in basing process called as spelter, and it has the melting point above 450 degrees centigrade. In brazing process, this filler rod will be in wire form, rod form. It could be in the ring form, or it could be in the shim form. This filler material is melted and fill inside this clearance by capillary action. Capillary action is the force that pulls the liquid material inside the joint, because there is a attraction between the molecules of the solid part and the molecules of the liquid filler material. This filler material is melted with the help of the torch, and from this torch heat will produce, that is used to melt this filler material. Filler material or filler rod is called spelter, as I've already told you. You can join any dissimilar metals from the brazing process. In brazing process, flux is used as well. This flux is used to prevent the surface from oxides, or it is also used to remove the oxide from the surface. And it is used to clean the uh, welding surfaces. In brazing process, flux is made up of borax, boric acid, borates, fluorides, and chlorides. Normally, boric acid and borax is used with water. It is used with water because if we use or if we mix this boric acid with the water, it will increase the capillary action or improve the wetting. What is wetting? Wetting, when the molten filler material will fill inside the clearance, it will adhere to the joint. This filler rod becomes fluid molten and can adhere properly to the component to form a very strong joint or to form a proper joint. The clearance between the fairing surface is very important, should be large enough to because if it is large, the molten metal will easily fill inside the joint or into the interface of the base metal and provide a strong joint or provide a strength to the joint. It is appearing with this graph, or it is showing from this graph. If you have a high clearance or the greater clearance, you have a good joint strength. Here there is some combination of the filler metal which are used or which are compatible with the base metal. If you use aluminum and silicon alloys, you can weld the base metal, aluminum metal. And if you have nickel alloys, you can weld the stainless steel and the nickel alloys. Filler materials, filler metal properties. Filler metal should have low melting point, or must be lower than the base metal. It should have good wetting property. I've already explained you what is wetting property. If this filler material becomes molten fluid and it will flow inside this clearance, it will adhere to this fairing surface. It will adhere to the fairing surfaces or will solidify into the fairing surfaces. That is the wetting. And flux is used to improve the wetting property of filler material. It should be capable of provide sufficient strength to the brace joint. Then lastly, it should have a low viscosity because fluidity of the molten metal must be high to form a proper joint. In the next second type of soldering, this is soldering. This is the second type, and it is very similar to the brazing. In soldering, the filler material called solder, and it has relatively low temperature. It has temperature. It has melting temperature below 450 degrees centigrade, and this filler material is filled inside this clearance by the capillary action. The normal filler materials or type of solders which are using in the soldering process, that is tin lead alloy, tin zinc alloy, and these are the base metals which are going to be soldered uh, with these alloys. This is the solder gun, and this solder gun has a temperature of 400 degrees centigrade. This is solder gun. Soldering is commonly used in the electronic industry. You can see the mobile repairer normally use the soldering to fix the mobile ICs. Capacitors are soldered or are welded with the help of the soldering process into the motherboard. This is the PCB board. This is the wire, and you can sold or you can form a joint with the help of solder. This wire can be welded with this PCB board with the help of soldering process. Flux is also used in this process, in soldering process, and flux is inorganic acids or salts. One commonly used compound is zinc ammonium chloride solution. In this solution, little quantity of water will also added, which is used to clean the surface of the base metal or the if you use this flux here in PCB, this is the base metal or base material, and this water which will be used with the flux, it is used to clean the surface of this PCB board. Non-corrosive resin-based fluxes are also used as a flux material. As you can see, it is written here, it is used typically in electrical application. Soldering has a wide application. You can weld a step-up transformer inside the power supply with the help of the soldering process.